In this video, we're going to look at transformations of parent functions. Now remember, a parent function is the graph before you do anything to it. And the first thing I'm going to talk about is just a little memory device to help you with knowing what transformations look like when it comes to certain equations. Now, when you have a change inside the equation, so maybe it's inside absolute value bars, or with a quadratic, it's inside the part that gets squared. What that means is the graph is going to be changed horizontally. So maybe it moves left or right, or maybe it's flipped horizontally, or stretched out horizontally. And it goes opposite of what you would think. So opposite direction of what you would think. And changes on the inside can affect your domain. If your change is outside of the function, so maybe it's outside the absolute value symbol or outside your x squared in a quadratic. If it is outside, it will move or change your graph vertically. Might help if I spell correctly. There we go. And it goes in exactly the direction you would think. So positives tend to go up, negatives tend to go down, things like that. And these can affect your range. So let's look at some situations here. If you have a number that is added on the inside of your equation, well, this means that it's going to move the graph left however many units you're adding. So inside changes move horizontally, left or right, opposite the direction you would think. So positives are on the right side of the graph, you actually move it left. So if I were to subtract a number on the inside, that makes it move right. Now changes on the outside, like on these two, move the graph vertically in exactly the direction you would think. So adding a number on the outside moves it up that many places. Subtracting a number moves it down that many places. So looking at some examples of these, and I'm going to take absolute values for example. The parent function of an absolute value is absolute value of x. So these transformations on an absolute value graph might look like this. So if I had f of x equals absolute value of x plus 2, this would mean that the parent function, absolute value of x, was moved left 2 places. If I had absolute value of x minus 2, this means we took the parent function and moved it right 2 places. So all of your points shifted right 2. Okay. If I took the absolute value of x and then added 2 on the outside, this moves the graph up 2 places. If I were to subtract on the outside, it would move it down. And you can always look in your calculator and see what kind of things these do. So for instance, the absolute value of x is our parent function. And let's say I wanted to graph this one, x plus 2. When you graph it, we can see the original and then the new one. It moved left 2 places. So these were all adding or subtracting. These two, we have it multiplied by a number. Now if your number is bigger than 1, like for example 2 absolute value of x, what it's going to do is it's going to do what we call a vertical stretch. So absolute value of 2 times absolute value of x would mean it's stretched vertically by a factor of 2, which if we were to graph this, we can see that the absolute value function, it's taller and skinnier. It's like they took the graph and then pulled it up. So that's why we call it a stretch. Now, if your number is between 0 and 1, it's called a vertical shrink or vertical compression. So, for example, if I took the equation half times the absolute value of x, this would be a shrink by a factor of 1/2. So, oops, wrong one, there we go. If I were to graph this, I can see that the graph becomes like shorter, flatter. It's like they took the graph and squished it down. Now, a negative is a reflection over the x-axis. It flips it upside down. So, there we go. So there's the original, and there's the reflection. It flips it upside down. So an absolute value graph might do something like this. Okay. So let's just look at a couple of other examples and see what kind of transformations are occurring with those examples. So I guess I can just make some stuff up. Let's take f of x equals -2 absolute value of x minus 1. There's 3 transformations that have occurred from the parent function. The negative does something, the 2 does something, and the 1 does something, because those are all different from the parent function. So this example, we have a reflection over the x-axis. It's a vertical stretch by a factor of 2. Let's write back 2, there we go. And then the -1, it's on the outside, so it moves it down 1 place. Okay. So another example, f of x equals 3/2 absolute value of x plus 3 minus, or plus 2, whatever. Lots of 3's and 2's. In this one, there's also 3 things that were done. We've got the 3/2, this 3, and this 2. So the 3/2, don't let the fact that it's a fraction fool you. 3/2 is bigger than 1. So that is a vertical stretch by a factor of 3/2, or 1.5. The plus 3, well, inside changes are opposite what we'd think, so instead of going right 3, because inside is horizontal, it actually moves left 3. And then plus 2, outside changes move it vertically exactly the direction you would think, so that's up 2. One more example, and then I think we'll be done. So, and I've been doing f of x, let's change it up, let's do g of x. Same thing, it's just a different function. So, let's take absolute value of x minus 4, and let's make that 1/3. Absolute value of x minus 4. Okay, so on this one, there are 2 transformations, here and here. The 1/3 means we have a vertical shrink by a factor of 1/3, So it's 1/3 as tall. And the -4, inside changes move it horizontally, left or right, opposite the direction we'd think. So it's left is what we would think, but it's actually going to the right. 4. Alright, and that's it for today.